just, it sounds like everyone had really great discussions. I think that there was a good energy. So each group, your goal is now to present what you talked about, your ideas, what you're going to maybe work on tomorrow morning as you continue to develop this idea. Again, if you were in a group that you were like, oh, maybe I'm a little less inspired by this, and I get really inspired by another group, you're of course welcome to swap groups tomorrow morning and start thinking about other topics. So with that, I will hand it to you, Joe, and have fun.
I'm not sure if I should be the representative for the group. So Joe Dufek's going to bail me out of everything wrong I say. Does that sound good? Okay. So we're the Cycles of Eruptive Activity group. And this is the project we came up with over 2 hours of heated discussion, not very heated, casual discussion, right? So what we would like to do is get magnitude and frequency data from volcanoes with good geologic characterization that also have some historic activity or some frequent historic activity. And some bonus data would be some volume and composition data. And the idea there is that you're going to compare the geologic to the modern record and say, what are we missing, right? The geologic record is often not fully preserved. You're probably missing a lot of, let's say, low magnitude events, things below VEI4 or something like that, in the geologic record that we would be observing in the modern record. And there's probably a two-way street here of things that the geologic, how would I put it? It can go both ways. Make of that what you will. This is why I'm not supposed to be the representative of this group, right? Anyway, so, right, in the geologic record, I guess another way it could go is that in the geologic record, you're capturing a longer time period, right? So you're getting both longer term cycles and shorter term cycles that could be preserved in the geologic record. How is this expressed in the modern, right? You have modern volcanoes that often look like they're not very active, but you look at their geologic record and you can see that when they are active, maybe they have lots of events over a short period of time or something like that, right? This is part of the whole two-way street here. And so how can modern monitoring, like the things we understand about a volcano today, help fill in some of the geologic history, fill in some of that history that's not perfectly preserved, right? And then the screen sharing is blocking that. This could help populate a new like stratigraphic database part of GeoDiva or something like that. So we had too many possible target volcanoes, and if you can think of more, that sounds great, right? We're looking for places with modern eruptive activity and some good geologic characterization, right? So we have a array of 4 of them up here, but again, if you have other ideas, feel free to ping members of the group, basically. I'm not sure how long these are supposed to be, so I'm just going.
Yeah, take your time. I was just gonna see what this.
Oh, it's all good.
You keep talking.
So the target volcanoes, we listed 4, but we're open to other ones.
That's a good one.
Yes, totally a good one. We're looking for volcanoes with stratigraphic data, right? You need like good, well-exposed stratigraphy. You need geochronologic controls or just dates on that stratigraphy. You need to know roughly when these ashes were coming out or things like that. And ideally, it has a modern eruptive history that has ideally also had some monitoring too, right? The oral history is super important. We want that plus modern monitoring on top of that, right? And then the geochemical constraints are important because you find an ash layer in your stratigraphic sequence, but you don't necessarily know if it's from the nearest vent or not, or it could be from a completely different island or something like that. So you need some geochem too. It's all good. In terms of personnel, in addition to the group members, we need some database support, right? People who really love trawling through databases and pulling out data and stuff like that. That's everybody in this room, right? You all love database work. There's a lot of this data, especially the stratigraphic data, that's probably just sitting in field notebooks somewhere, and that data has to get basically digitized, right? Not all of this is necessarily easily enterable into existing databases. And then we need good volcano stratigraphy and good volcano stratigraphers, someone who can make a call on whether this, 2-centimeter ash layer is actually an ash or not something else, right? That can get tricky. So some benefits, it could populate a new stratigraphy section of GeoDiva. That was one of our initial ideas, right? And then we could better understand the cyclicity in these systems, right? Things that are not so active today. What is their actual cyclicity? Is this a business as usual or not, right? And with some of this cyclicity knowledge, we could better inform some more like novel monitoring strategies or methods or things like that. So that was our basic overview in 2 hours. Thanks, everybody. Yeah.
Any questions or recommendations for this group?
Hi, you spoke of long-term and short-term cycles. Can you give a number of what that means in terms of years?
It's a great question.
Days.
It's a great question for Joe, who's going to bail me out of everything. Go ahead, Joe.
Think we're thinking cycles, so I don't think it needs much more than 10, 20,000 years, right?
We're talking about the Holocene,
Yeah.
unfortunately. It's a good geologic record.
Something we're talking about are like, there's 3 different time periods. There's like stuff that's recorded only in the geologic record. There's stuff that's recorded in like personal record, where it's like, okay, what did you see? If people were on the island or on a boat that they have records of. And then there's things that you can see in the monitoring record. So it's like, how can we bridge these 3 time periods?
And I'll just read Cheryl's comment, which is, in what we are missing, traditional ecological knowledge might contain info for many volcanoes and be some help. So that's a great suggestion that could also be included.
Yeah, ties right into what you were just saying.
Yeah.
Yeah.
Well,
Thanks, crew.
Mattia?
Mattia?
That's the geochemical data. So for the group of speaking about magmatic diversity along the arc, if your data would be very interesting to have your geochemical data, so be our database. So vice versa, if you're producing data that would be of interest about these volcanoes, we can be the one providing. That's as a
We'll gather all the data you want if you pay for it.
one data, one bottle of wine. So
That's good.
Bottle of wine.
Perfect. Anything else? All right, well, thank you.
Thanks.
Thank you. All right, Mike, you ready? Like you just need to gas.
Everyone knows what that means.
Everyone knows what that means.
Everyone knows what that means. Yeah, so our group was thinking about what are the data gaps for the volatile record in the Aleutians, the Alaska-Aleutians. Because ultimately we want to try to connect melt inclusion data sets to volcanic gas data sets. So first we wanted to identify some targets, think about like what are the things that we could really do as a community and like where we should focus our efforts. So what can be done now? Sort of thinking about like Mattia's comment that like maybe funding is going to be tight in the near future. So what can we do? And also what probably needs to be funded as maybe a community effort, and think about how we want to do that collectively. So one of the things that kept coming up in our conversation was that the Cook Inlets don't have very much melt inclusion data. There's not a lot of great melt inclusion data for intermediate systems in Alaska in general, or globally in general. So Redoubt and Spur now have some that are coming out, but the rest of the Cook Inlet volcanoes really need some melt inclusion data, and they're great targets actually because there's such good gas data. There's annual flights, multi-gas that goes around, and so we have some really good gas data sets to compare future melt inclusion data sets to. And we want to sort of explore the potential of forward modeling pathways based on different scenarios, shallow degassing, recharge, sort of what's the steady state background, and kind of try to move a little bit past the open versus closed system degassing models. So tomorrow, I think our group is going to focus on sort of a systematic compilation of the existing data that's out there and try to identify critical gaps and identify specific samples, specific eruptions at some of these volcanoes. We also were talking about how petrologic evolution and eruption history at different volcanoes is really important for providing the context to interpret these data sets. And in some places that's better than others, and for some eruptions that's better than others, and that might inform which eruptions we want to target. And then things that probably we need to like band together and try to get funding for. We were really excited about the idea of sacrificing a bunch of multi-gas systems, and the best way to do that was a source of contention. But if we could put out multi-gas systems at the summits of volcanoes as they're starting to enter states of unrest, and just see how those signals change over time, that would really be powerful. Something that we kept coming back to is that we really need good CO2 data at systems and good carbon and sulfur ratios to understand how different levels of magma in the magmatic system are degassing or moving up and sort of integrating the whole system when we think about volatile gas data sets. So we want to organize the gas and melt inclusion data sets that are available, and we sort of had 5 groups of that we think we can put our data sets into. One where melt inclusion data are good and there's reconstructed CO2 for those melt inclusions, and there's also good gas data sets. We can go ahead and start to model. There aren't lots of these systems out there, so we're going to really have to focus on getting more CO2 reconstruction of vapor bubbles or rehomogenized melt inclusion. So the second group is we have melt inclusion data, or we need to know more about the CO2 and compare that to existing good gas geochemistry. The third group was where we had good gas data but no melt inclusion. So let's just do all the work. Group 4, we have poor gas or no CO2 gas data, and then, you know, variable quality, maybe even very good melt inclusion data. And then group 5, we just don't know anything. So those are going to be sort of our categories and help inform the targets we want to make. So just a very quick list of things that target volcanoes we were excited about. If we have any information about CO2 and melt inclusions, that's reconstructed or Raman measurements of CO2 and vapor bubbles. We have a short list: Cleveland, Veniaminoff, Redoubt, Akhmach, Shishaldin, Sagwam, Pavlov. These are all either published or largely in the works. So those are already targets that people are working on. And then we identified 3 eruptions that we think might be really important targets: Pavlov 2016, Augustine 2006, and Spur 92/25. We'll see. And then a few more where we have some pretty good gas data: Ilyamna, Korovin, Makushin. That might be good additional targets. And I think that might be it. Yeah. Any questions?
Questions, comments, ideas?
Overlook volcanoes.
Mattia?
To better understand the different analytical and probably I assume also experimental efforts. So in detail, what are you going to do? Like what instruments, personnel you need? I don't know if it's premature in the light of the discussion you had. Some of you are going to quantify tomorrow.
Yeah, we started having that conversation once Madison told us it was time to like walk back here. So that's something else that I think, you know, tomorrow we'll talk about, yeah, what needs to be done. But it's a really good point. I think experiments like really are going to inform a lot of our interpretations for sure.
Thanks.
All right, thank you. Next on the docket. Can't see. I hate this thing. Go away. Okay, I think. All right, who's our speaker? You, sorry? Yeah, the speaker.
Yes.
Thank you.
We had no shortage of volunteers to present, but I'll just outline the, as the leader, I'll just outline what we're thinking about right now and love to get people's thoughts. So we're the Magma Diversity Group. And the centerpiece here on the opening slide, this is from one of our group members, Jordan Luber. It's 2023 GQ paper, I think. Is that right? Yeah. Where, Jordan when we sort of opened the conversation was wide ranging, energetic, and my fingers could barely keep up with all the great ideas people had. So I really appreciate all the hard work the group did. So in thinking about sort of the challenges that we face with the Aleutians, this paper really highlights where these 26 identified tephras for major explosive eruptions have sort of been sourced to, and where analyses have been done or not. Is that right, Jordan? Is that?
Yeah, those are basically all the volcanoes that AVO thinks have the potential to either produce other forming eruptions or large regional tephra producing eruptions.
Yeah.
And the green are volcanoes we have data for, and the red are ones that we do not.
Yeah.
So there are holes, there are gaps.
And these gaps are not just constrained to the, an individual eruptive sequence that AVO might be worried about. Looking across the arc, this is a figure. I can't remember if in Mattia's presentation if this figure showed up or if another one was broken.
Didn't show up. Finally, is
Okay, so you can finally see Mattia's now, which is great. So this is his master's thesis student's work. And what this sort of shows is, so we have these gaps where we have major explosive eruptions that are not characterized. We also have gaps in terms of our understanding of, how the diversity, the origin of compositional diversity in the arc relates to changes in things like depth of slab, the slab obliquity, convergence rate, and other tectonic characteristics. And then thinking further back in sort of like the state of compositional diversity broadly, this paper from JICA 2004 shows longitudinal bend variations in trace element ratios and radiogenics. And for any folks who've worked in the Aleutians, you're probably familiar with these types of trends. But the key thing is that, in keeping with this workshop's theme this week, AVO has a lot of whole rock and trace element data. This was made clear to us by the folks in the group who work with AVO or work for AVO. But there's a lot of gaps in things like isotopes outside the central Aleutians, glass measurements, which are very difficult to do on microlite rich glasses from across the arc, as well as, individually, there's not glass available from a lot of these different centers that could produce big eruptions. And mineral scale analyses are something that, being documented in GeoDiva, but are very kind of locationally spotty, whether or not you have them or not. A final thing that's like really important for thinking about arc diversity, this was made clear to us by the AVO folks, is that this process of binning by longitude, maybe not the best way of thinking about how we think about arc diversity at scale. So this is a slightly modified approach that Matt and Jordan were showing me just before, literally as we were walking in the room. And it's a really simple way of relating a long arc distance via Hayes 2018 SLAB 2.0 model and trying to represent diversity in different ways. So these are some of the challenges we were thinking about. We had lots of kind of thoughts on how we could address some of these challenges, different scales of diversity and their controls. And so briefly, I'll outline some really interesting thoughts we had and love to get your ideas on it. So our project, we're hoping that we can come up with sort of a strategy for assessing some of these research questions you see on the screen here. Most crucially, we want to find, a handful of systems, 2 or 3, where we can really well constrain everything from source to sort of most evolved, and reconstruct a single line of descent and address some of these big questions going from granular at the sort of magmatic scale, sort of the crystal scale, out towards tectonic controls on magmatic behavior. And then there's some of these other tectonic questions here. So as we were sort of going through our conversation, we sort of stumbled upon sort of the different things we need to address some of these questions, where this magmatic diversity comes from, different types of materials versus different types of analyses. And we're sort of we're sort of in the process of figuring out how we're going to break it all out now. So the embryonic form of this, I sort of outlined here, is we were dominated by geochemists and petrologists. So that might give you a hint as to why this talk has been structured this way. But we have a really important need for working with tectonicists, geodynamicists, people who understand things like deformation and crustal structure, so that we can make sure that our workflows that address things like source and magma evolution have some sort of basis in tectonic fact. Really important we relate diversity back to tectonics. And once we decide sort of the structure of these 3 working groups, who's going to work on what and how, we're going to chunk up the arc into different segments based on availability of AVO existing samples. So yeah, need a lot of people outside of geochemists. That's the main talk here. And these are sort of our beginning of our analytical breakdown of what we need to get done. The big thing I'd like to emphasize is that we're looking for ways of controlling for analyses. Basically, we want to do these analyses in a way that see reanalysis at different labs of the same sample, so that we get internally and externally consistent geochemical results. We want to make sure that the results speak to sort of a new way of thinking about arc segmentation. And we want to make sure our data can be structured in such a way in its output that it can be immediately imported back into GeoDiva, making the GeoDiva's team work a little bit easier. And to Mattia's point, I think this is a theme that's really resonated with a lot of us. We think this project is achievable with existing AVO samples, and we don't necessarily need to do new field work given current funding environment. Might be a good constraint. So yeah, thank you.
Any questions, comments, ideas?
I do think that as we talk about more of these, it's especially clear that there can be a lot of like every time, like every one of these, I'm like, man, that would help us, and I'm sure we could help them. I feel like, you know, all of these can work alongside each other very nicely and complement each other in quite a few ways.
Yeah, absolutely. And actually, I had a note somewhere in our document. I need to talk to Mike because we have some melt inclusion ideas, but wait, that's your thing. But we like to collaborate. Yeah. Oh yeah, your group. Well, you presented it. I don't know who else is in your group, but yeah, we'll chat. Yeah.
Yeah, just send them along.
Yeah.
Yeah. Cool.
All right. Thank you.
Next, thank you. That was great. I feel like I have one more, but I should have two more.
It's off your wiggle.
Oh, gotcha. Thank you. Wiggle. All right, you will save Wiggle for last. Okay. This you? All right, take it away.
All right. Oh boy, this is intimidating. Okay, so I should start by saying that I do have a stutter, so I will skip or jump or stop. Just be patient. All right, so yeah, we were looking at essentially the storage and ascent of volcanoes throughout the Aleutian arc. And immediately what we wanted to do was we eventually came to the conclusion that instead of doing a very focused approach on a couple, what we wanted to do is kind of explore as many volcanoes as possible and build a very basic interpretation. So the questions that we want to answer are: where is magma stored, and how quickly does it rise, and how quickly is it's quick? So is it rising slowly, and then is it erupting quickly, and that sort. We'll have more as we go. So what we wanted to do first is make a compilation of what we know on as many volcanoes as possible. This would be pretty as in-depth as we can get, but from there we can identify gaps in the knowledge and where more research would be targeted, as well as areas where we have a lot of info that hasn't really been analyzed. And one of the main things that we want to do is to So one of the things that we want to do is to take our data. I feel like I'm rushing, but I'll get to more as we do. To take our data and to do stuff and to do analyses which can be done quickly and get results back quickly. And so when we have a lot of volcanoes, we can do all of our quick analyses on them and make a basic framework of, okay, so we can take the petrological and the seismic and the geodetic, and maybe we don't have a whole lot of data, but we have enough to get a very basic framework for every volcano. And then we can build off of that as things progress. And in this case, if we got something like an Edgecombe, where it was not a priority and then suddenly begins to erupt, we have a place to start with our research on it. So a lot of volcanoes, we don't know a lot about the magma system or the ascent rates or anything like that. And so having just at least a basic model can help to confine those. And as well as you make these models, you can use things that you learn from some to benefit other ones. And then the other goal is to determine the magma ascension rates. There a lot of the DLP events, they could be caused by slow magma ascent, by quick magma ascent. Are the ways that we can tell that from the petrology, from the seismic, or from the geodetic. And then when it begins to erupt are the ways that we can say, oh, there's magma moving, but it's moving a lot quicker now. Could that be an eruption? And so analyzing essentially what we have already instead of collecting a new material, especially as has been said a lot now, what you don't know that you will have the money to go get more material. So having these easier, cheaper, and quicker analyses can really help to get a lot of data compiled and build on these frameworks so that you have a bit for everything. And then I guess I can wait on that. Additionally, if you found a volcano which you really want, which you either didn't have a lot of info for, or you thought was a high priority, those could be targeted and chosen, and then really more work could be done on those to get more data or to analyze it more in depth and to build a better understanding of those, which would especially be great if one starts to rumble or becomes a higher threat. So essentially what we propose are a number of action items, and I don't think it would take a terribly large team to do a lot of these. It would really be a lot of initially compilations, and some of these have been done or are being done, and so we could piggyback off of those or use a similar method or framework for those. And this could really incorporate a lot of the databases which exist or are proposed to be created. From there, we could then take what we have, either whole rock samples or geodetic data or seismic, and just begin to build on any knowledge gaps which we find in our new compilations. And then using all of the old and the new data, we can compile these frameworks. Where is magma being stored in the volcano? How quickly is it rising? Can we use that to predict eruptions? And then from there, if there are any high priority ones, those ones could be targeted, and any funds which could be gathered could then be put forward to do more in-depth research, such as metal inclusions or installing new instruments, and in the end, just to create something for as many volcanoes as we can. If it's just a basic, there is a high magma chamber or a low magma chamber, or if it is a full out geophysical map of the locations and the ascension rates and the crystallization rates, even anything which we can get from these data. And I believe that's about it. So, yeah.
Any comments or questions for this group? Matthias?
Thank you very much for your presentation. I'm afraid that MELS may be useless on anti-group building systems. So like MELS, unfortunately, will not work probably for the illusions especially.
Right. Okay.
So you have an alternative with MELS probably?
Well, we were essentially just kind of tossing out ideas, but we might.
Comment. So F-volt actually not super prevalent in ocean magmas for most of our systems, but for a few it is very present. So yeah, those volcanoes definitely won't work.
So probably for some targeted volcanoes, MELS is still
Have to be judicious ahead of time to make sure that we're choosing the right system.
Thanks.
Yeah.
Any other comments, ideas? Yeah. All right, last group.
Right.
Thank you, Jack.
Thank you.
Wiggle time. Oh, Hannah really dug in.
I mean, I'll take responsibility.
Oh my God.
I didn't add that. Kendall, did you?
I added that, yeah.
Oh, okay. Great.
It's descriptive.
Okay. Last few slides of the day. Take a deep breath. Prepare yourselves. Most of it won't look like this. This is to catch your attention before we throw a bunch of text in your face. Kendall and I'll tag team this somehow, but we haven't
Yeah.
planned it, so
No.
we'll see how this goes. Oh, that's okay. So to start with, we had a wide-ranging conversation over 2 hours, some of which devolved into griping about how our terminology is confusing and we can't make everyone use the same language, and some of which was a little more productive. But fundamentally, the things that I got out of the conversation about what we want to understand, I mean, volcanoes, obviously. But that's big, right? So digging down a little bit, we're interested in a couple specific things that really jumped out. One was eruptions and precursors and unrest that happens and is not followed by an eruption. And yeah, that's not the terminology question, but we're going to call it that. The causes and sources of seismicity, and trying to derive a process-based understanding of what produces the wiggles that we stare at for so much time. And then correlations between seismicity, geochemistry, and deformation are obviously, well, maybe not obviously, they're confusing, they're interesting, they're things that we would like to know more about. And we just put tremor on there as a big category. And I won't say anything else about it because I don't know anything else about it. But if you're interested in that, talk to Darren.
Yeah.
Next slide.
So we came up with a couple project ideas. We were trying to be more interdisciplinary, so because we were mostly seismologists and we know that we can get a lot more information by talking to geochemists and petrologists and all of you. So some of the projects we came up with was a bit what the last group also talked about, was making a large catalog across different kinds of data sets for organized by volcano, so that we can really get more data out of each system and look at periods of unrest that aren't immediately followed by an eruption versus those that are, and maybe what makes the difference there. Which also goes into the second one, which was the fact that there are different definitions of unrest. We think a lot of the seismic one, but there's also examples brought up of like Mount Baker that had a gassing episode with zero seismicity, or if there's an analog with deformation, and what does the different types of unrest tell us about how each system is evolving. We also talked about investigating spatial clusters of events where the different types of seismicity are mixed from higher frequency to lower frequency, and depth and whatnot. We listed DLPs on here because there's still a lot to learn. Just across the board. If we can find more in time series records that haven't been cataloged, if they can tell us about source processes, and if there's connections to tomography that we can make. And then cataloging weird phenomena like tremors that we don't really understand.
Yeah, I mean, the one thing I'll add to that is
Yeah.
that John already left to go pick up his kids, but he said when we started making this list, that sounds a lot like homework.
Yeah.
And maybe it does, and who knows if anyone in the room would actually volunteer to make this catalog, but it would be great if it happened.
Yeah.
So what we actually need, continuing with the theme of we have a lot of data and we should use that first before trying to go get more. I'll start the list with something that we should maybe get more of. Continuous gas data came up over and over again. I think I highlighted it in 5 different colors in our notes document. So that's one of these things when we're spending a lot of time talking about differentiating between different types of seismicity. We might agonize a lot over it because frequency is not actually a great differentiator for these kinds of things. But folks who look at things like continuous gas data might find it a little less mystifying to think about the processes behind the different types of wiggles we look at. So we'd like more of that, please. The other thing that we definitely need is non-seismic expertise. In a room full of seismologists, it was clear that we needed insights from geodesy, petrology, things like crystal clocks, to get any kind of system level understanding of volcanoes. We do need some collation of data so we know what we have. Connor might lead an army of undergrads to make this happen someday, or maybe not, I don't know. There was some discussion of having a desire for standardized catalogs and taking the pre-events model of going back to the long time series we have from some volcanoes, or decently long time series, and using standardized processes to get as much out of them as possible in a consistent manner, as well as gathering imaging results from different locations that might be in just a variety of publications strewn through the literature. We would like consistent terminology, but as the Wiggle Rodeo title of this presentation indicates, we don't have it and we're probably not going to get it. But hey, we can start in this room. Maybe we can agree on some jargon and bring it out into the world with us and try and get other people to use it as well. Last slide.
So who would be involved in this is everyone. We're focusing a lot, like I said, on the interdisciplinary stuff, so we really need perspectives from all sides. Most especially AVO when they have time and resources and the energy to give. And then, like Hannah said, a lot of this sounds like the kind of thing that we can throw on undergrads and as not busy work, but learning, yes, I love that. The sort of the cataloging and bringing data together from multiple different areas of the literature.
Right, literature review is a legitimate thing for people who want to learn more about this part of the world. It's a good way to do it. And I think the other thing that Jackie brought up is that sometimes people at AVO, it sounds like, come across interesting things in the data and don't have time to investigate. And if you have time, or someone you know has time, start a collaboration. So I think that's all we have.
Yeah.
Any questions or comments for this group?
I have a comment in the last slide. We talked about continuous gas data, and I think a fundamental reason why that came up so many times is because seismology has the highest sample rate out of all the disciplines at volcanoes. And if we could upsample the other disciplines, it makes it a lot easier for us to correlate data sets. So now with scanning DOAS, that's one checked off the list, but it'll be nice if we have higher sample rates for the other disciplines.
Yes.
Yeah, one of the rare times seismologists are pitching for it.
Finally. Well, thank you. Woo-hoo. All right, maybe I can stop sharing. All right, well, I think now my job is to mostly tell you what we're doing in the next 24 hours. Which maybe I'll just stop sharing. I'm sorry. Sharon, Abby, I guess we'll see you tomorrow. If that's okay. Okay. Okay, so most importantly, the idea would be to discuss what we are doing tonight. Yeah. Oh, okay, that sounds good. Do you want to come give a update? Okay, come on down. Apologies, I missed that. Are there slides in here on for you? You only have notes, but there's notes in here?
Yeah, there's notes.
Okay. I got this. Here we go. All right. Can I make this big? Is that a thing? Whatever. Okay. There you go. That seems pretty good.
Thank you. So our topic was basically like related to landslides and avalanches in the Alaska-Aleutian Arc. And the big question we had was, do we need to really study these landslides and avalanches there? And mostly the goal of this topic was really to just form like a discussion for addressing this issue, which is associated with the volcanic and seismic activity that's found in the Alaska-Aleutian Arc. Let me scroll down. So there's been a case study of a tsunami occurring on April 1st of 1946, where a landslide was triggered by an earthquake and it caused a tsunami in the upper Aleutian Arc. And you can see in this figure right here that this is where it occurred. And so some problems associated with this topic is that excuse me, volcanic and seismic activity trigger landslides on unstable slopes and edifices of volcanoes. And then if they're near like any body of water, they can also trigger tsunamis, and whenever these like landslides fall into the body of water. And most of these landslides in this area occur unnoticed and are not monitored. In addition, the Alaska-Aleutians are not highly populated areas, and landslides are typically monitored in areas that pose hazards to community and infrastructure. And mostly they would be they would be considered natural processes if human safety was not affected. And also volcanoes that have like lateral collapses like Mount St. Helens are actually not that rare. There's been existing evidence of ancient volcanoes where you can see like the crater shape of it, also like a possible landslide when they have like sector collapses that might have been related to possibly like the magmatic plumbing of it. And also the glaciers in the Alaska-Aleutians are retreating, which are also revealing unstable land that was originally held up by the glaciers. And so the threat of these landslides are also increasing especially in the seismically active areas. And there's no real-time monitoring of the landslides along the Aleutian Arc. There's and this is where you can see where the real-time landslide monitoring stations are located, which you can notice they're mostly along like areas that are like populated. So some possible uses for data sets is doing field work, doing using some sort of a slope assessment program where you can use you can rate and categorize slope instability, probably like focus on more like the eastern Aleutians which are near communities, using seismic data set to monitor these landslides where we can like use existing data already instead of like having to create new data. And we can also use infrasound and geodetic data as well as tilt meter data if it can be incorporated, and also possibly a modeling of slope instability. And that is what I got for y'all.
Thank you.
Any questions?
So this is actually a comment, but it occurs to me that detecting the slopes that could be done using a satellite. It could probably be automatically characterized with machine learning and like a very basic, like if we assume this amount of grade is like generally unstable, that amount is potentially unstable. So that could very potentially be done very quickly too.
That's a good idea, actually. Satellite.
Yeah. Excuse me, number one for suddenly landslides, I'll throw my hydrophones out there again, because that's a great way to see if there's activity offshore at small or large level. Secondly, with respect to small ones or land-based ones, I think this goes also back to this question of categorizing seismic activity and making sure that we have terminology, because we do see in seismic data a huge number of avalanches, a huge number of glacial slip events. They're not always identifiable in a database. It just depends on how complete the database is with respect to superficial events. So it's another place where we can be really careful about how we group those. So each other.
That's good to think about.
Thank you.
Thank you.
Yeah. Is it fruitful discussions? All right. On your